ready to carry on? Well, turns out I actually lied. We have a couple of other things that we do still need to do, but we are still going to do the cooling channels next. And for this, this is probably not going to be enough cooling for the mold. I'm not going to run this through the full mold flow analysis though right now. So we're going to insert, you see I just clicked right there. Now we need some reference edges, and we want to reference off the top and off of the side. And I'm picking the outside rather than the inside of the chamfer, just because it's entirely possible that we're not going to have the chamfer on there when we mill these. So I'm going to edit this one. I'm going to set it 5 inches in from the outside face, and we'll make this one 0.4375, 7/16 away from the top, and that looks nice. Now, I want this. You can see it's not going all the way through right now, and I definitely want that to go all the way through. So I'm going to change distance, change that to through all, and you can see that we've got our channel, and then we've got kind of a counter bore here. And what that is, that's a counter bore for an 1/8 inch NPT, which is going to be 0.273 inches deep. And then we've got a 315 drilled hole. And we actually are going to want something on the other end too. And we can insert opposite pipe thread and counter bore and whatnot, but we could just hit symmetrical. And then it's going to be, the same fitting on both ends. And I'm not going to mess with this. Like I said, that's probably insufficient cooling for the mold, but I'd want to run it through simulation mold flow to really take a look at the cooling. And hit OK, and we need to go back and we need to do this now 3 more times. And again, we want these two to be our reference edges, 5.4375, and it remembers that we did through all and symmetrical, so it defaulted to that on this one as well. Hit apply. Now down here we need to be a little bit more careful because we've got ejector pins, and I'm still picking well, not the same edges, but the ones that correspond to the same thing. It doesn't look like we're going to run into problems with our ejector pins on this side, and we'll do 5 inches and bring this down. Let's see what 0.5 looks like. That looks good. Hit apply again, and then do the same thing on the other side here. 5 inches and 0.5. And now, since that was the last one I needed, I'm going to go ahead and hit OK. And if I really wanted to, I could make these, by putting them in only a certain distance, I could have them 90 over and come out from the other side, or I could create a very complex series of cooling channels and passages, and I could create a lot more than just those 4. But in the interests of time, those are the only ones I'm going to make. Now we're going to go ahead and hit cooling channel check. And what this does, it lets us define a minimum safety distance away from our cooling channels, just so that we can be sure that we're not intruding on any important parts. And we want to go against all cores and cavities and all mold base plates. Hit preview, and you can see that that's the safety zone that it's creating. And wow, that actually cuts all the way through our core and our cavity. That's probably going to be okay. I mean, this is not a very big hole, and so 3/4 of an inch is probably a little bit too much. Let's cut that back a little bit. We'll take a look at 1/4 of an inch, because that's, you know, almost the full diameter of the tubes. And you can see, even at 1/4 of an inch, we're still impinging on our core section a little tiny bit on the cavity as well. But we are plenty clear of our ejector pins. Yeah, get a little bit of impingement on the sprue bushing, but again, the amount of pressure that we're going to be running these at, we're not likely to be forcing, we're not going to blow anything out here. Do an interference check next, and this just compares against the ejectors and mold-based components to make sure that we're not, you know, impinging on a guide or a ejector or anything. So hit start, and there's no errors detected. Again, preview, it does the same thing. And then cooling system check, make sure that we're not going to run into anything on the cooling system. They're not going to screw up your flow path by crossing over. And of course, obviously, there's no errors detected since everything's parallel. So we're done with that. Now you come back over here to mold assembly, and the last parts that we need to add are the cooling components. And we have a lot of different things that we can add here. Right now we're looking just at barb fittings for cooling lines. But I mean, there's tons of things we can do. We can add, you know, pipe plugs. We can add heat transfer pipes, seals. We can scroll up here. You can see we can add, you know, baffles, and all. There's tons and tons and tons of things that we can do. But I'm just gonna put little plugs in here, and we're gonna go with. Oh, sorry. No, we need 1/8. Because that's the size that we set. So go ahead and select the edge there, hit apply, edge, apply, circular edge, again, apply, and keep doing that all the way around. And that's the last one, so we'll hit OK. And you can see we have all of our little fittings done there. And now there is one very, very, very important thing that we haven't done that we probably ought to. And this is actually the last thing to make this mold. And what that is, right now we've got our nice chunks of steel there with the core and the cavity, but we don't have any holes in our base plates for those to sit. So we're going to go ahead and create a workpiece pocket. Now, there's a few different things that we could do here. We could simply just merge the core and the cavity into the base plate, but you know, nobody wants to do that, because then every time you can't just replace the inserts, you have to replace the whole base plates, and you know, your CFO will, you know, beat you soundly if you suggest he needs to pony up for that every time. So we can cut pockets, and a couple of different things we can do there. If we're doing wire cut, then obviously you can do, you know, little square corners here, but I'm probably going to mill these. I mean, if I was going to make them, so we'll do hole clearance. And this is just because, you know, a milling cutter which rotates can never make a sharp interior corner. And in this case, the tool that I'm going to cut with would probably be a 3/4 inch diameter end mill. So I'm going to go 0.75. And I'm going to hit OK. And that, my friends, is a complete injection mold designed in under an hour. from initial concept of the part through digital prototyping and all the way to mold design in under an hour. Go ahead and take a few minutes and finish out your mold, and then when you come back, we're going to do a little bit of simulation and some of the basic design validation tools that Inventor includes for the injection molds. So go to pause the video, take a few minutes, and come on back when you're ready.